Hi everyone, welcome to Vedantu J English. I'm Diksha, your chemistry master teacher. So everybody let me know in the chat box if I'm clearly visible and audible to you or not. Yes everybody, am I visible? Am I audible to all of you or not? Yes students, Siddharth, Shirom, Mona, Kavi, Netar, Nilvan, everybody. Okay, so this is going to be a mock test kind of thing for your BITSAT, right? So in BITSAT, firstly, let us see what is the exactly pattern and what are the number of questions that they can ask you in chemistry, right? So if you talk about the pattern here, we know that physics is there, chemistry, English proficiency, logical reasoning, mathematics, all of these things are there. And if you talk about chemistry here, that is for 30 questions will be asked here, and each question, this will be a computer based test, CBT test it is, not OMR sheet test. And here if you see, 3 marks will be given to you for every correct answer, and there is negative marking of -1 for incorrect answer, and there is no deduction obviously if you don't answer, right? Okay. And one thing about extra question is there, but for that you have to attempt all the 130 question without skipping, which is very rare, right? So in that case, if you're able to do that without skipping, only then you can attend the extra questions here, right? Okay, yes. Now this is the syllabus. You can go through this. I'll provide you the PPT in the description box. You can go through the syllabus here, right? There are some extra chapters also apart from JEE mains here, right? So that is the full syllabus. And now we are going to start with the questions. Okay, everybody, is that clear? And before that, let me tell you all the students here. Let me tell you here. Wait a minute. Okay, so in the description box, now is the time for the preparation, right? You need to have a test series for BITSAT, right? For that, we have BITSAT test series. 10 mock tests will be given to you, and that is just at 649. Okay, just at 649 it is available to you, BITSAT test series, and you can click here and you will be given with the BITSAT test series. You can view course plan, that is for 649 itself, right? And if you're preparing for other exams as well, then you have different test series for a specific exam, right? You can see that here. And if you're like, ma'am, I want all the test series, that will be more, that will be better for you. You can go for extra mile test series here, right? Okay, in that case, you will have all the test series here, right? Okay, so that's it. And now let us start with, but this BITSAT test series for BITSAT students is must to have for your practice, right? So that you can do well in exam. Practice is very important for you, right? Okay, students, yes. Now let us start this without wasting any time. And here the first question on your screen is, directions, consider the following reaction. So this reaction is given to you. So here what they have given is CH3, CHO, HCN. In that you have added HCN here in CHO, and you have CH3. Okay, so basically what we have, cyanohydrin. So here you have CH3, right? This is C double bond O, this is H, right? And here what you're adding H positive, Cn negative here, right? And now what will happen, this is H positive, this is Cn negative. This negative will attack here, electrons will jump here, and hence in the end what you will have, this will be CH3, right? C, this is OH, this is Cn, and this is H. Okay, so now here you have triple bond, right? This is C triple bond N. Now when you add water into it, in the presence of water, when you add water into it, what will happen? Pi bonds will break here, right? You should know the full reaction here. Pi bonds will break here, and you will have CH3, C, this is OH, and this will be converted to COOH, and this is H. Now can you see this carbon here? Because in the question what they are asking you, in this reaction, a symmetrical center is generated. What is that asymmetrical asymmetrical center, it is a chiral center here, right? So this chiral carbon is generated here. For asymmetrical center, what you should have for chiral carbon sp3 it should be, and or the 4 groups should be different here. Only then we can say it's a chiral carbon, right? Is generated. The acid obtained would be, what kind of acid will be obtained here? Yes, everybody, what kind of acid? So this acid is obtained here, which is because of chirality here, because of asymmetrical, it will give you optical isomers. That is why 50% D, 50% L will be formed, right? Or 50% D, 80% L will be formed, D isomer, L isomer will be formed. So answer will be 50% of D and L will be formed. So answer is going to be A is the correct answer here, right? A is the correct answer here, right? Okay. Second question on your screen, everybody. Second question. Let us see that. Second is, an organic compound of molecular formula C3H6O forms 2,4-dinitrophenyl hydrazone but gives negative tolerance test. Okay, so if you remember 2,4-DNP test, what exactly give 2,4-DNP? Schiff's test, 2,4-DNP test, what exactly gives you these tests? Anybody in the chat box? Ma'am, left, right, yes. So capital D is OH is on the DR. Yes, capital D is when OH is on the right side, and capital L is when OH is on the left side. Okay, that's how it will be differentiated, right? Okay. Now, an organic compound, some organic compound is given to you. We know that it is going to show you 2,4-DNP test. That means it is going to be definitely a carbonyl carbon, right? This will definitely be there. Now they are saying that it gives negative tolerance test. Now, tolerance test is given by aldehyde. Tolerance test is given by the compound is this. Negative tolerance test. Okay, negative tolerance test. So, if you see this here, I think it should be, but gives negative tolerance test. Double bond carbonyl is not here. Carbonyl is not present here, right? This is not present here, right? It's here and here, right? So out of these two, this gives positive tolerance test because it is aldehyde. So they are talking about negative tolerance test. So this will not give you tolerance test. So answer will be C is the correct answer, okay? Answer will be C is the correct. They are asking you that it should give negative tolerance test. Tolerance test is given by aldehyde. So that means this will give positive tolerance test. This will give negative tolerance test. So answer will be C is the correct answer. Is that clear, students? Okay. Answer is going to be C is the correct answer here. Okay. Positive tolerance test means aldehyde, right? So we need a negative tolerance test here, right? Okay. Next question on your screen, students. Next question, option C, ma'am. Yes, very good, very good, very good. Yes, option C is the correct answer here. Right. Next question is, ionization constant of acetic acid is this. The concentration of H positive ions in 0.1 molar solution is. So ionization of acetic acid they have given you. If you talk about the acetic acid, so we know that Ka is equals to C alpha square. Now ma'am, how can you say that Ka is equals to C alpha square? First thing is, when you have monoprotic acid, then Ka is equals to C alpha square, right? But still, if you want to know the full detail of this, then it will be CH3COH, which is a weak acid. Yes, then after that what we are going to do, we are going to substitute it into CH3COO negative and substitute, I am saying dissociate into CH3CO negative and H positive, right? Now if initially let's say it is C, it is 0, it is 0. Now stoichiometry, this initial concentration multiplied by alpha will be subtracted, C alpha will be formed, C alpha will be formed. So Ka is equals to product is C square alpha square. That means C alpha whole square is C square alpha square. Now here you can take C common, 1 minus alpha, CC cancel, it will be C alpha square 1 minus alpha. Now degree of dissociation is very small in comparison to 1. So right, you can directly write it as C alpha square. Either you should directly know also, okay, this you should know also, that what is this is for students who are like confused about the derivation, then this is derivation. Otherwise, you should know also that for monoprotic, when you have monoprotic weak acid, right, in that case it is Ka is equals to C alpha square. C is the concentration, alpha is the degree of dissociation. They are asking you ionization constant here of the acetic. Acha, ionization constant is given to you. This is given to you. They are asking you the concentration of H positive in 0.1. Okay, concentration of H positive they are asking you. So what you have to do here, you have to calculate the value of C alpha, right? That means first you will calculate the value of alpha, that is equals to Ka divided by C, right? Okay, first you will calculate the value of alpha is equals to Ka divided by C. We know that H positive concentration is equals to C alpha, right? H positive concentration is equals to C alpha. So I'll put the value of alpha here, that is Ka. I'll just put the value of alpha here, that is under root of Ka, this is C. Now can I also write this C as C square under root? If I square it, then I put under root here, that is nothing but C only, right? So I can also write it as under root C square Ka divided by C. That means H positive. I don't prefer that you should learn these learn these kind of formulas. Otherwise, you might learn it wrong, or you might get confused in the exam. So you can also derive this. It's not a very big deal, right? So H positive is equals to under root of Ka multiplied by C. Ka is given to you, so you can just directly write. They can also ask you the pH value here, pOH value here. pH value will be what? Everybody, firstly let us see what is H. That will be under root of 1.8 into 10 raised to power, this is -5 multiplied by 0.1. You will take the under root of this thing. pH is equals to minus log of H positive, that will be your pH value. pOH is 14 minus pH, right? So you can calculate pH, pOH, anything from this, right? So that is going to be the, after doing the calculations, you will see that H positive concentration is 1.34 into 10 raised to power minus 3. Okay, next question, students, next question on your screen. Next question, students, everybody on your screen, right? Okay, let us see that 1 mole of a complex compound, that is this compound, right? That is this compound. They have not given that which is outside the coordination sphere, which is inside the coordination sphere. So no worries about that. Give 3 moles of iron. So let us see who is able to answer this. Let us see who is able to answer this. Attached session PDF. Yes, definitely Nexa, that will be attached. Ma'am, is there any session coming for Comet K? Please tell. Definitely, you tell us if you want a session for Comet K. Just write it down in the comment section. We'll definitely take that. Right? So, your demand will tell that what we will do here, right? Okay, so if more students are interested in Comet K session, so definitely we're going to take that, right? Okay, so 1 mole of complex compound, that is this, gives 3 moles of iron on dissociation in water. That means, can I get an idea that in the coordination sphere 2 moles are outside? I don't know which one. 2 things are outside. This is full coordination sphere. Only then it can give 3 moles of iron. 3 moles of ions. Only then it can give 3 moles of ions on dissolution in water. 1 mole of same complex reacts with 2 moles of AgNO3. Now they are saying that we know that chlorine acts with, when chlorine Cl negative, when chlorine is outside the coordination sphere, it will act with AgNO3 to give AgCl. If we are saying that you have 2 moles of AgNO3 is reacting with 1 mole of this compound, that means here 2 Cl are outside. That means here I can say 2 Cl are outside. 2 Cl are outside, that means directly you can write it as CO, NH3, 5, and this is Cl, and coordination number is 6 here. So answer will be what? Answer will be A will be your correct answer here. Is that clear? A, ma'am, very good, very good, very good. That will be your correct answer here, right? Next question is, in which pair, wait a minute, Yes. In which pair they are asking you of ions both species contain S single bond S? Okay, so there is SS bond here in which of the following pair that you have to tell. So directly for this you should know the structure here. So you can see that in SO4 2 negative, wait a minute, this is not SO4 2 negative, this is S2O3 2 negative, right? Very important compound, right? This is a very important compound, right? So here you can see there is direct S double bond, SS bond is directly here, right? Okay, from the structure it is clear that there is SS bond, so answer you are going to be C is the correct answer here. And S4O6 2 negative also has the same, right? It also has SS linkage, right? Only then you have oxygen, like it has this kind of linkage, SS linkage. Then here you have 3 oxygen, here you have 3 oxygens, okay? And 1 sulfur attached to this case, 1 sulfur attached to this one. So this also gives you SS bond. So answer will be C. You can see this here, that here you can have, wait a minute. Basically all are given to you, right? So this is what I was talking about, right? So here you have S4, here you have S4. Ma'am, these are from which, basically ma'am, this topic is from which part of the syllabus? So when you see P block, right? In P block, very important, you have phospho-oxo acid, you have sulfur oxo acid, okay? So from there we have these structures directly in your NCERT from where this question has been asked, okay? So for this you need to know the full structures here. If you talk about this is the second part, that is S4O6, right? This is 2 negative here, right? So directly you can see that sulfur has bond. Otherwise this does not have sulfur bond. There is SO-S bond linkage. There is peroxide linkage of oxygen here, right? So definitely no sulfur bond is present here. So answer will be C is the correct answer here, right? Okay, next question is select the incorrect statement about the following reaction. So firstly tell me, what is this reaction? What is this reaction, students? What is the name of this reaction? Anybody? Very simple. What is the name of this reaction? You have to select the incorrect statements here. Incorrect statements. And there will be only one incorrect statement because it's not multiple answer question. So there will be only one incorrect statement here. This is Williamson synthesis reaction. Very good. So Williamson synthesis reaction follows SN2 mechanism. That is true, right? So that is the correct answer. That is the correct statement. Second is alkyl halide should be 2 degree or 3 degree, while alkoxide should be primary. That is not at all correct, because in Williamson synthesis your alkyl halide should be primary. Only then this is possible. Only then this reaction is possible, right? So alkyl halide, that means RX should be primary here, right? So this B is not correct. That means B is the correct answer. Let's see the third one. Alkyl halide should be primary, while alkoxide, that means this is your alkoxide, RONA, right? So alkoxide should be 2 degree. That is true. Now let's say you have 2 degree, 3 degree alkyl halide. Let's say you have this. Then what will happen? So in that case, what will happen? It will undergo E2 elimination in the presence of strong base to form alkene. That is the reason alkyl halide should be primary. That means this is also true. So incorrect statement is B. That is the correct answer here. That means B is the correct answer here. B is the correct answer here, right? Okay. Yes, very good. Next question is, now this one is a very interesting question. Let us see if you're able to answer this or not. It's easy yet interesting. Why? Because in a different manner this question has been asked, right? So if there were 3 possible values, they are saying that we know that S, that is spin quantum number, that has only plus half and minus half value, right? In reality, it is only plus half and minus half. Let's imagine that it also has 0, right? We are imagining this, that it also has 0. So it has 3 values here, right? From the spin magnetic quantum number, how many elements would be there in 4th period? So elements will be equals to what thing? So if you see, in the 4th, if you say 4s, there will be 4p, there will be 4d, right? This thing will be there, right? Okay. 4th period they are asking you. Okay. So in 4th period we have 4s, 4p, 4d. In this case, if you see, you have only one dabba. You have here 3 boxes, right? Here you have 5, right? Or if I tell that directly also, you can say that here m is equals to only 0, that is 1. Here m is equals to minus 1, 0, plus 1. Here m is equals to, this is minus 2, minus 1, 0, plus 1, plus 2. Now earlier what we were saying that in one orbital only 2 electrons can go. Why? Because one will be opposite spin should be there. One is plus half, one is minus half. Here we are saying that there are 3 spins. So that means in each box there will be 3 electrons here. So 3 will be here. 3, 3, 3. It will be 3, 3, 3, 3, 3. So this is 3 into 5, that is 15. This is 3 into 3, that is 9. That is 3 into 1, that is 3. So total it accounts for 9, 12, 12 plus 15, that is 27. Hai na? So answer will be C, right? 27 elements would have been in the 4th period here. Right? Okay. So instead of 2 electrons, you are filling 3 electrons here. That is the only different thing here. Right? So 27 elements will be there here. Right? Okay, students. Now, next one is calculate the Rydberg constant. Now, this is interesting. Right? So, calculate the Rydberg constant, RH they are asking you. Right? So these are the values that is given to you, right? Are known to have wavelength difference between first lines of Balmer and this and this. Now, if you talk about, there are 2 things here. There are 2 things. Firstly, you should know the formula of Rydberg constant. So we know that 1 by lambda is equals to RHZ square, 1 by N1 square minus 1 by N2 square, right? This is the Rydberg equation. We know that if you talk about, let's say Lyman series, in Lyman series, okay, tell me in Lyman series, what is the value of N2, right? What is the value of N2? That is going to be, what is the value of N1? What is the value of N1? It is going to be 1, N2 is going to be 2, because they are talking about the first line. First line means longest wavelength. Longest wavelength means minimum energy. Or even if they give you first line, or they can also give you alpha line. They can also give you alpha line here, right? Alpha line, first line, minimum energy, longest wavelength, or correspond. So you just have to add 1 into the N1 value, right? That will be your N2. Now, if you talk about Balmer, in that case, what you can write? N1 is equals to 2, because Lyman Balmer passed in bracket P fund, right? So here N2 is equals to 3, right? Okay. Because first line only they are talking about. So one by one we'll put these values. If you talk about helium, let's say here they are talking about difference between helium, they're talking about just one atom. Calculate the Rydberg constant of this helium and not to have the. Okay, so that means they're talking about only helium positive. Now helium positive has Z is equals to 2, right? So that means Z you will put is equals to 2, right? N1, N2 will variate, right? You'll have to calculate the value of lambda 1 here and lambda 2. Here you will calculate the value of lambda 1. Here you will calculate the value of lambda 2 in the terms of RH, right? So after this, delta lambda is given to you, that is given to be 133.7 nanometer. Because the options, the answers are in meters, so we'll convert it into meter, that is 33.7 10 raised to minus 9 meter, and hence you will just subtract it because they have given you the difference between lambda 1 and lambda 2, right? So you'll take lambda 2 minus lambda 1, the mod is already given to you, then easily you can solve this answer. Okay students, ma'am didn't understand? Okay, see, this is the Rydberg equation, right? This is Rydberg equation. They have given you what? They have given you first line of Balmer and Lyman series, right? So that means two cases are given to you. Lambda 1 corresponds to Lyman series. When you have Lyman series, N1 is 1, N2 is 2. Balmer series, N1 is 2, N2 is 3. For first line means you have to add 1 into it, right? Okay, now they are talking about helium positive. So helium positive, Z2 is equals to 2, right? So basically what you have to do here, right? You're like, ma'am, you have left a question on us, so nothing, it's just calculations we are left with. 1 by lambda 1 is equals to RH2 square, because Z is equals to 2, right? So this is 1 by N1 is 1 square minus 1 by 2 square. Okay, so you'll have to solve this. Then 1 by lambda 2 is equals to RH, this is again 2 square, this is 1 by 2 square by 1 by 3 square. Okay, you have to solve these two equations, right? And then you will put it here, lambda 2 minus lambda 1, which is already given to you in the question. From there you will calculate the value of RH. Is that clear? Right? Okay. Right. Okay. Okay. Understood? Yes. Now, next we have, yes, this I think, okay, that was given to you only, right? So you can easily calculate this. 1 by lambda 1, that will correspond to 5 RH by 9. 1 by lambda 2, that will come out to be 3 R by 1, right? Then you can subtract these two things, that will corresponding to this thing. You will subtract, and hence you will get your answer here for RH. Is that clear, everybody? Is that clear? Okay. Okay. Okay, understood. Yes, everybody. Yes. Next question here is, for the cell, so this is based on Nernst equation, directly you can see they have given you this cell here, R E naught reduction potential of this 2 are given to you. Both reduction potential are given to us. Even if they have not mentioned reduction potential, you can see that reduction potential means oxidation number will decrease. So oxidation number is decreasing from +2 to 0, +2 to 0. That means both are the correct things here, right? Okay, now next we have is, next is for the cell, this is given to you, what is the value of E cell? We know that E cell is equals to E naught cell minus 0.059 divided by n factor log of. Now for this we have to solve this, we have to write the reaction here. So we know that Z is getting converted to Zn2 positive, right? And copper 2 positive is getting converted to copper, right? So that means if you write product by reactants, you can write product is Zn2 positive, reactant is Cu2 positive. So this will be Zn2 positive divided by Cu2 positive. This you can write. Okay. Now what is the value of E naught cell? Anybody, what is the value of E naught cell? E naught cell is equals to cathode minus anode. What is cathode? Always remember AC. Okay, so this is anode. Whenever you have cell representation, this side is anode, this side is cathode. Okay, so here also you can see that at the anode side it is losing the electron, so Zn is losing the electron, so that's why it is anode, right? So here you will write E naught of Zn, right? 2 positive to Zn minus of E naught of copper, right? Both the reduction potentials only you will write. So this is minus 0.76, minus 0.35. That will be your E naught value. That you will put here. What is the value of N here? Anybody? What is the value of n factor? How many electrons? Here also it is, how many electrons it is losing? 2. Here how many electrons it is gaining? 2. So that means n factor is going to be 2 here, right? So you'll put the value of n as 2. What is this Zn by Cu? Zn is given to be 1, Cu is given to be 2. So it will be 1 by 2. That is 2 raised to power minus 1, right? So this will, wait a minute, I'll just write it here. E naught cell minus 0.0, you can write it 6 also, divided by 2. Log of 1 by 2, you can write it as 2 raised to power minus 1. You can write it as minus minus plus log of 2. That is 0.301. Okay. By this, you can easily solve this. Is that clear? Okay. Let me see, 1.109 it is coming out to be. Wait a minute. Zn is getting converted to Acha, here directly they have put positive here. That's the reason. Okay, you solve it like this, what I have told you, right? Then you reciprocate, right? Here they have directly put the value positive here, right? Inversing this thing, right? You don't need to get into that, right? Okay, yes. Next question on your screen we have, for a reaction at equilibrium, this reaction is given to you. The relation between dissociation constant and degree of dissociation and equilibrium pressure is given by. So now this is the sort of derivation. Okay, this is a sort of derivation. For this, you need to know some very, very important things about, basic things about equilibrium, that if you say, let's talk about, okay. So if you talk about this reaction here, right, we know that what is Kp? Kp is equals to partial pressure of B multiplied by partial pressure of C raised to power 1 by 2 divided by partial pressure of A. That is the value of Kp, right? What is partial pressure? Remember that partial pressure is equals to mole fraction into total pressure, right? Okay, so equilibrium pressure is the total pressure, that is given to be P, right? Relation, what is the relation in dissociation constant? K and degree of dissociation, this and this. Okay, so one by one we will solve this. Firstly, why I have told you this thing? Because first you will calculate number of moles in terms of degree of dissociation. You will multiply it by P, right? Then you will get the partial pressure. Then you will put the partial pressure in this equation. Then you will solve it and you will get your answer. It's a lengthy problem, right? But it's simple problem. Okay, so I'll just solve it for you here. Right, so if you see this, this reaction is given to you. Okay, so whenever initial moles are, understand one thing, whenever initial moles are not given to you, what you have to do there, whenever initial moles, either you take it like what is the stoichiometry, or you take it as 1. Here stoichiometry is also 1, and we can also take it as unity as well. Even if the stoichiometry is 2 or 3, we can take it as unity, right? But according to that, like things will vary here, right? If I put 1 here, right, this is 0. Initially, when things are not at equilibrium, there is no product formation. Now, whenever, like we did for CH3COH, right, same thing I'll do here. 1 minus this concentration that I have taken, that is C multiplied by alpha. C is equals to 1. Okay, that number of moles, initial mole is 1, so it will be alpha only. This is alpha and this is alpha by 2. Ma'am, why this is alpha? Because stoichiometry multiplied by alpha. Stoichiometry multiplied by alpha. So that is alpha by 2. Is that clear? Is this step clear to everybody or not? Is this step clear to everybody or not? Start class 11th. My ambition is to write VEEE and course. Please help me throughout the year. Definitely Harish will start that. Okay, don't worry about that. We'll definitely start that, right? Okay, so this is alpha by 2. Is that clear to everybody? Shall I? So because after I have like completely solved the question, then you ask me, what was that first step, right? Then it will be tough for me. So you tell me whether this is clear to you, only then I can jump to the next step here, right? So here, mole fraction, what is, firstly you talk about what is mole fraction. It is number of moles divided by total moles. Total moles is 1 plus, total mole is NT is equals to, NT is equals to 1 minus alpha plus alpha plus alpha by 2. That will cancel out. It will give you 1 plus alpha by 2, right? Okay, that is 1 plus alpha by 2. Now, if you see this here, you need to divide it 1 minus alpha, this moles divided by total number of moles, that is 1 plus alpha by 2. This moles divided by total number of moles, this moles divided by total number of moles is your mole fraction. Now, you have to multiply the mole fraction with the total pressure, only then you will get the partial pressure, right? So you'll have to multiply it by the total pressure or equilibrium pressure that is given to be P in the question, right? Now you have the partial pressure in terms of alpha and P, alpha and P, alpha and B. Now what you have to do, everybody, now what you have to do, anybody in the chat box, now I'll put it in the value of Kp, right? So Kp value is, according to that equation, it will be Pb because it was A give rise to B plus 1 by 2 C. So it will be Pc raised to power stoichiometry, Pb raised to power stoichiometry, Pa raised to power product by reactant it is, right? So you have the value of Kp here, right? Now Pb you know, Pc you know, Pa you know, that we have calculated here. Now you will put all these values here and then you will solve it and then you will get your answer here. Is that clear? Right? Okay. Then you will get your answer here. Okay. Understood? Yes, students. Is that clear? Is that understood? Right? Okay. Next question is regarding considering the reaction. So this reaction is given to you, C plus O2 give rise to CO2 plus. This means energy is released here. Whenever energy is released, delta H is negative. And we know that this is a combustion reaction. In combustion reaction, it is delta H is negative. Delta G is also negative because it's a spontaneous process. Combustion is a spontaneous process, right? So that is why delta G is also negative. Entropy is positive here, right? Entropy, randomness is positive here, right? In combustion, entropy is positive because two molecules, different molecules are combining together, right? That is why entropy will be positive. So answer will be delta H is negative, delta S is positive, delta G is negative. So answer will be A is the correct answer here. This is a direct question, okay? Direct fact-based question, okay? Yes, students? Okay? Yes. Next, we have highest osmotic pressure is shown by a solution of which of the following. So, highest osmotic pressure, we know that pi is equals to CRT, ICRT, right? Concentration is same here. R is same, temperature is same. That means osmotic pressure is directly proportional to I. Now you need to tell me in which, see, when alpha value is not given to you, that means you will take alpha is equals to 100% dissociation. That means I is equals to N. N is the number of moles dissociated, right? So if you see this here, aluminium sulfate, that is Al2SO4 thrice, we know that it will give you 2 of Al3 positive and 3 of SO4 2 negative. That means total 5 number. After dissociation, you have total 5 here, right? So this is 5, I value is 5 here. Potassium nitrate is KNO3. Both of them will give 2 moles. One is K positive, other is NO3 negative. Magnesium chloride is MgCl2. It will give you Mg2 positive plus Cl negative, that is 2. So total 3 it will give. Barium chloride is BaCl2. Again it will give you 3. 2 Cl and 1 Ba2 positive. That means maximum is for A. That means A is the correct answer here. Okay. Right, answer is A, ma'am. Very good, very good, very good. Okay. Okay, next question is, okay, this we have done. For a reaction, now here, this is from chemical kinetics, okay. So in this, some reaction is given to you, right? We don't know which reaction, some reaction is given to you. when the concentration of A and B both were doubled. We are saying concentration of A and B both should be doubled. Okay, the rate of the reaction increases from 3 to 2.4. Oh, so that means it will be 8 times it is increasing, is it? है ना? Yes, it is increasing. That means rate is increasing 8 times. This is I am talking about with respect to A. Okay, so here how you need to solve it. Firstly, we will solve it with respect to A, with respect to B. Firstly, we will keep any of the concentration constant. First, they are saying when the concentration of A and B both were doubled, the rate of the reaction increased for this. That means A dash is equals to 2A, B dash is equals to 2B. In that case, R dash is equals to 8R. A rate is increasing by 8 times. Till here, we are still blank. So, we'll talk about the next point here. When the concentration of A alone is doubled. When we are saying alone A is doubled, only A concentration is doubled. Okay. So, A is doubled here. In that case, rate increases by 2 times. Now, this will give you the answer, right? R dash is equals to 2 of R. Here, can I write that B is constant? B is constant here, right? So, here what we will do, after this is A is doubling, B is constant, but rate of reaction is also doubled, right? So, that means I can get a hint that this R dash is equals to, this is R, this is x raised to power n. Now, what is this x raised to power n? X will be the times the concentration is increasing. We will take only one part here. If I'm applying this thing here, I need to keep one thing constant. Okay, I need to keep one thing constant. So this x is representing how many times the concentration is increasing. So we know that it is increasing 2 times. So I'll write it as R dash is equal to 2 raised to power n of R. We also know that R dash is equals to 2 into R. That means, can I write here that 2 raised to power n is equals to 2? That is only possible if n is equals to 1. That means, see, those students who are not able to, this is for those students who are not able to visualize this only by seeing that, okay, if A dash is increasing, R dash is doubling, then order should be 1. Okay, directly also you will be able to understand this. But if the question becomes tough, right, let's say they have written it is becoming 8 times, 10 times, then this thing will be very easily you can answer this thing, right? Okay, so here with respect to A it is 1. So that means here what I'll do, with respect to A it is 1, that means R is equals to A. With respect to A, this I don't know, this I don't know, I'll write M here. Okay, now if with respect to A it is 1, that means R dash, if I am doubling the concentration of A, R dash will get doubled, right? That we know. That means easily we can say that if I put B is equals to, let's say I put B, let's say I put with respect to B it is 2. Let's do hit and trial here, right? Let's say this happens, then R dash will be equals to 2A raised to power 1, 2B raised to power 2. In that case, it will be 2. This will be 2 into 2, 4. This will be A. This will be B. Okay. So that will be 8 times. That means that is true. That means with respect to B, it is going to be 2. So we can say order of reaction with respect to B is 2. That is correct. Total order of reaction is 3. Okay, total order of reaction is not 4, it is 3, right? Order of reaction with respect to B is 1, that is not true. Order of reaction with respect to A is 2, that is also not true. So answer will be B is the correct answer. Is that clear? Okay, students, B is the correct answer. Okay, right? Okay, yes. Okay, let us talk about next question here, right? According to the molecular orbital theory, now they have given you molecular orbital theory. Which of the following will not be variable molecule? Variable means which will not exist. Which will not exist. Which will not exist. So you have to tell which of the following will not exist here. For that, what you will do? If we say which of the following will not exist, for that what you will do, very simple, right? So here it is helium, right? Okay, so let's say first here we'll talk about helium only. Helium, we know that it is 1s2 2s2. Helium 2 is what? Helium 2 is what? Let's put it in sigma value. We know that helium 2 is how many electrons? Hydrogen, helium 2 electrons, right? And 2 into 2 is 4 electrons here. So it is going to be sigma 1s2 sigma star 1s2, right? So here if you calculate the bond order, right? See, bond order is going to be anti-bonding minus bonding by 1. Anti-bonding minus bonding divided by 2. So that is going to be 0. Okay. Let us calculate for helium 2 positive. If you take out electrons from here, right? In that case, what will happen? Sigma 1s2 sigma star 1 is 1. Right? Here bond order is going to be what? Here bond order is going to be, we got our answer, but still I'm going to solve it for others as well. Bond order is going to be 2 minus 1 divided by 2, that is 0.5, right? Very unstable molecule it will be. Hydrogen, we know that that has 2 electrons, but when you add 1 electron, that will be 3 electrons, right? So it is going to be sigma 1s2, right? Wait a minute, there is no option like helium 2. Oh, there is no option like helium 2. Okay. Helium 2 is not at all in there in the option. Okay, then we can't say this. So this will have 3 electrons. So it will be sigma 1s2 sigma 1s sigma star 1s. Again, bond order is going to be 0.5. Same as this, right? For helium, for hydrogen 2 negative, you will add 2 electrons here. It will be 4. It will become the same as that. So bond order for 4 is going to be 0. Okay. Now, this we have not solved. Helium, right? This we got that helium, hydrogen 2 negative is 0. Helium 2 positive is what? Helium 2 positive means you take out 2 electrons, that will become sigma 1s2. That is bond order is equals to 2 minus 0 divided by 2, that is 1. Okay, so we got our answer that for 0, whenever bond order is 0, that is the unstable molecule. Okay, so here it is going to be H2 negative, right? D is the correct answer here, right? Which is not viable molecule because bond order is going to be 0 here. Bond order 1 is stable, bond order 0.5 half is unstable, right? But bond order 0 means it will not exist only, right? It will not exist only. Next question is, this is from practical chemistry, or you can say this is from qualitative quantitative analysis, right? So the color, some very, very important compounds, the colors, everything you should know. What is the formula, color? This is important, right? So the Prussian blue color obtained during the test of nitrogen by Lissagany's test is due to the formation of Prussian blue. That compound is also called Prussian blue, right? That is a very, very famous compound. What is that? Anybody in the chat box? You have 1 iron outside, 1 iron inside, right? So it is going to be A is the correct answer here, right? That is your Prussian blue, right? Okay. Next question is, right, that you will get, that is Prussian blue, right? Next we have, okay, this is the full length answer is given to you, right? So I just told you directly that what is the color of the compound and what is the formula, right? Next is, which one of the following compounds will consume more equivalents of aqueous solution of AgNO3? See, if it has to consume AgNO3, that means it should have more Cl negative. Only then it will give you AgCl. That means you need to see which has maximum number of Cl outside. Okay, so you can see here you have 2, here you have 3 Cl outside. So it will give you 3 AgCl here, right? So answer will be C is the correct answer here, right? Okay. Now we are starting with the organic questions here, everybody. We are starting with the organic questions. So let us see that. Let us see. I think it is mixed only. Okay. Identify the major product that forms easily and faster in the following reaction. right? So this reaction is given to you. They are saying which compound is formed easily and faster here, right? Okay, so this is a very good reducing agent, but this is a selective reducing agent, right? Selective means it is not going to reduce COO, CH3 or NO2. It will only reduce this COH into CH2OH. Okay, so answer will be, this will be as it is, this will be as it is, this will be converted to CH2OH, right? Ha. So answer will be, yes, answer will be B is the correct answer here, because it is a selective reducing agent, right? So it only reduces some compounds, not all the things. You can't say NO2 will be converted to NH2. These are the properties of the reducing agents that you should like know by heart, right? LiLH4, NaBH4, Dibble, then this B2H6, all these you should know these things, okay? Which they reduce, which they do not reduce, right? Okay, DMSO, right? Very, very important. Next is correct solubility order of AgF, AgCl, AgBr, AgI in water is what? See, solubility means the interaction with water. The one which has strong interaction with water, its solubility will be more. So you tell me which has strong interaction in water. Definitely you have F negative. We know that F and this is water, right? So they will form hydrogen bonds here. That is the reason the solubility of AgF will be maximum here, right? So answer will be, as you go down the group, it will decrease. So answer will be B is the correct answer here. B is the correct answer here, right? Okay, understood? Next question is the radius of first Bohr orbit of hydrogen atom is this. The radius of Bohr orbit having n is equals to, okay. So they are saying the radius of first Bohr orbit, that means A naught is given to be 53.4 picometer only. They have given, they have asked you the answer in picometer only. Now everybody, this is a very, very famous question, right? So directly you can say that Rn is equals to R naught n square by Z, right? So we know that n value is 3 here, right? Lithium Z value is also 3 here, so that will be R naught 3 square by 3. It will cancel out. It will be 3 into 53.4 picometer. That will be 160 around it will be. So answer will be D is the correct answer here, right? Okay, yes. Okay, you can see that D will be your correct answer here. Next question, everybody, on your screen is regarding geometrical shapes. So this is from inorganic chemistry, right? Geometrical shapes. Now here the important thing is you should like know that, like if you have gone through enough examples, right, easily you can solve this, right? So nickel, they have not told you what is the compound, what is the formula of the compound. They have just given geometrical shapes of the complexes formed by reaction of Ni2 positive with Cl, Cn and water is. So nickel, if you have gone through enough questions here, you would know that with Cl it forms this kind of compound. With the Cn it forms this kind of compound. Wait a minute. That should be 4. This kind of compound. With water it forms Ni and this is water and this is 6. Right, and here it is 2 positive. So these are the 3 compounds that it forms. Okay, that you should know. Only then you'll be able to answer this, right? There is no nickel H2, water is 4, water is 6. It forms octahedral, right? So here, right, with chlorine it generally forms 4 coordination number. It sometimes forms 6 also, but usually, generally, because nothing is given to us, we will talk about general thing. Generally it forms 4, right? So here if you see, we know that this is a weak field ligand, right? See, about this we know that it is going to form octahedral only. Either it will be inner octahedral or outer octahedral, right? So we don't even need to solve this. This will be octahedral only. So this option is eliminated here, right? Out of these two, if you want to see, we have Ni2 positive here. We know that nickel is 4s2 3d8. Nickel 2 positive is directly 3d8. Nickel 2 positive is directly 3d8. Okay. So nickel 2 positive is directly 3d8. So when we know that nickel 2 positive is 3d8, we know that if in a strong field ligand, what will happen? They will be pairing 1, 2, 3, 4, 5, 6, 7, 8. So you will be left with only one d orbital. So we know that in coordination number 4, either it can be sp3 or it can be dsp2. So when you are left with only d, that means dsp2 will be the correct answer. So dsp2 is nothing but it is square planar, right? So answer will be square planar. So that means with Cn, that is strong, it will be square planar. That is, this is the correct. So this is not correct. Why? Because NiCl4, 4 coordination number can never be octahedral. So this is also eliminated. So answer will be B is the correct answer. Ma'am, why for Cl it is tetrahedral? Because see, it is no pairing. So it will be 1, 2, 3, 4, 5. 5d orbital. It will be 6, 7, 8. Right? So you are not left with any d orbital here. So it will be directly sp3 here. So it will be sp3. It will be dsp2, that is why it is tetrahedral, it is square planar. Okay, so answer will be B is the correct answer. Let me see how many of you have answered this. Yes, ma'am. dsp2, option C. C? No, option not C, option B. Okay, B is the correct answer. Okay. Now this is a very interesting question, because you can easily solve this within seconds. You can solve this, but for that you need to know the proper core concept here, right? What is the concept that we are using here, right? So here if you see, they are saying correct energy profile of amine inversion, right? So amine inversion, it's like first it was like this, then suddenly it will go like this. That is the inversion, right? Inversion, like umbrella you have, that gets inverted, right? So here you have this amine, you have this amine, that is totally inverted. So one thing you should know, that whenever you are inverting it, once it will go to a square planar geometry where nitrogen will have sp2 hybridization, right? When it is transferring, right, here it is in tetrahedral geometry, right? But when it is inverting, it will get converted to a square planar geometry. That will be the intermediate, that is sp2. So sp3 is eliminated. Here you have sp2, here you have sp2, right? Now if you can see here A and B have same energies. Here A and B energies are not same. So when, see, if you see this compound, there is no new compound that is formed. It's just getting inverted. So inversion, it is in 3D. That means the energy of both the compound is going to be same, because that is just the inverted product here, right? So that is why the energy should be same here. So answer will be D is the correct answer here. Okay, D is the correct answer here. Is that clear, students? Is that clear? Okay, D is the correct answer here. Right? Next question is, examine the following resonating structures of formic acid for their individual stability and then answer the question given below, right? So this thing is given to you. Here you need to know how to tell the stability of resonating structures, okay? So if you see the stability of resonating structure, one thing you should be clear that point by point you have to see. First point is, I'll see whether there is any neutral species here. Yes, neutral species only first one. So first will be maximum. 1 will be maximum. Second point is, I'll search for pi bonds. The more the pi bonds, more is the stability of resonating structure. I know here you have one pi bond, here you have no pi bond, no pi bond. That means you'll say, ma'am, both have one pi bond. No. You have to go point by point. First point is, you will see that neutral is more stable than charged. Okay. Once you have seen that first is more stable. Now all are charged. Now look for pi bonds. This has one pi bond. So that is going to be maximum stable out of these three. Third point is, I look for the negative charge here. Negative charge is more stable down the group and along the period. Down the group also negative charge stability is increasing, along the period also it is increasing. So we'll say that definitely nitrogen, because oxygen, here you have carbon and here you have oxygen, carbon, nitrogen, oxygen. So oxygen will have more stable negative charge here. So that is why I have told you along the period, down the group, because we usually remember that negative charge is stable in more electronegative element, right? But down the group also you should remember, right? Okay, along the both of them negative charge is increasing, right? So here this is more stable, then you will have third, then you will have fourth. So it is 1, 2, 3, 4. So answer will be B is the correct answer here. Okay. Achha, one more thing. After this also, if you're not able to get the correct order, then you will see the charge separation. More the charge separation, less is the stability. Okay. Charge separation and stability are inversely proportional to each other. More is the charge separation, less is the stability. Right? Okay. Yes, everybody, B is the correct answer. Next question on your screen. Right? Some very, very interesting questions we are doing. Yes, negative charge on more electronegative element is more stable. Definitely, that is correct. Right? So, if you see this here, firstly is Mg ether, that means Grignard region. See, if you have Rx and you're adding Mg here, you have the formation of RMgX, that is the Grignard region. That means in the first case, you will have the formation of Grignard region, that is this thing. Okay. So that is nitrogen here, right? This, here you have MgX, MgBr. Now, you have PHCHO. You know what will happen? Just after this, what will happen? You will have the, because this is going to be an acidic medium, we are going acid also. So what will happen? This H positive is going to, this not, here what will happen? This is H. So this H positive is going to replace, right, interchange, like mean intramolecular rearrangement will happen here. This hydrogen will go here and this MgBr will be formed here, right? Understood or not? Intramolecular rearrangement will occur here. Intramolecular in one molecule only it is the rearrangement is occurring, right? This is where students might do things wrong, right? Okay, so after this it's easy only. After this you will take this as R, this as MgBr. After this it's not a big deal, right? So I'll just write it. After this what you're going to do, here also it is written. Chalo, I'll just write it here. Here you have this thing and this is intermolecular acid base rearrangement is happening. So this is the compound that you have. This is PHC double bond O. We know that this is C, this is double bond O. We know that this is less electronegative. So what will happen here? Negative part, okay, the one that has electrons, because we know that nitrogen has lone pair of electrons, so it will attack the electron deficient site, right? And this MgBr will be attached to this site. So it will be O negative, this will be MgBr, this is positive, and here you will have this N will be attached to this carbon. So this carbon will have one pH and one nitrogen with this ring. Got it? This carbon will have this pH already attached here, and this whole ring will be attached to this carbon, that is this thing. Right? After adding water, this MgBr will be replaced by H, and this is the final compound that you will have. Is that clear to everybody? This is the final compound that you will have here. Right? So answer will be B is the correct answer. Yes. B is the correct answer. That is, this is the correct answer here, where you have NCH, PH, and this is OH. Right? And there is one chiral carbon also here. Okay. Yes, next question is give the best conditions. Now they are asking the best conditions for this transformation, right? So this is question is given to you. They have asked you the best condition for this transformation. See, if you're going to transform this, so what we will need here, basically this is C double bond O, this is H, right? So if you add CH3OH here, CHO, right, this is positive. We know that this O will attack here, right? Okay, electrons will jump here and you will have CH3. This is 1, 2, 3. This is carbon. This is O negative, right? This is H positive, and here you have the attachment of OCH3, and this is hydrogen, right? Because this will attack here. In this Mg ether you have, and here you have SOCl2, and here you have water. I believe this is the correct answer. Reason being, because after this, what will happen? Again, you have CH3O negative. It's not like only one molecule will be there in the beaker, right? There will be millions of molecules, right? So what will happen? One more molecule will attack here, and it will replace this OH2 OCH3, and that will be your answer here. That means A is the correct reagent here. A is the correct reagent here, right? Okay. So A is the correct reagent. Next question is, let us see that. Choose the most reasonable reaction intermediate, for the following reaction. So are you loving the questions that we are solving or not? Are you loving? Are you able to solve the questions or not? Everybody let me know in the chat box. Are you liking it? Do you want more of it? And do you also want very brilliant, amazing test series for BITSAT, right? If you're looking for a very amazing test series for BITSAT, where, you know, the questions according to the latest pattern in last 5 to 6 years, what kind of questions they have asked, according to that, those kind of questions will be there in the test series. For BITSAT, we have BITSAT test series. 10 mock tests will be given to you. Now, right now you have time, right, to actually go for, like, you can actually solve all the 10 mock tests within this time, right? Okay, so that is possible for you. So I would really advise you, this is the BITSAT test series. You can just click on here. That is just for 649. What is that, right? Just 649. You are getting 10 mock tests, right, with solutions you are getting here. So you can click on this link and you will have 10 full syllabus tests, test series, helps in BITSAT exam. Everything will be there. And if you're preparing for any other exam, then you have different, like, individual exam based test series is also there. Every test series is at 649, right? And for that particular exam you will get 10 mock tests each, right? And if you're looking for like all over test series, then also you will get the link for, I'll just add on the link for extra mile test series, where all the test series for all the exams are provided to you. So that's totally your choice what you want to do, right? But definitely test series are very, very important. See, just looking at me that I am solving the questions, it's not like you will be able to solve the questions in the exam. You will get an idea that what ma'am is solving. If you want to solve that in the exam hall, then you should do it yourself. You should be able to manage the time, right? Everything, in fact, logical reasoning, everything is there in the test series, right? So those things also, those areas also you can be confident on after giving the mock test, right? Okay. Yes, ma'am will be that. Let's see the firstly exam. No, I am not antaryami, right? So choose the most reasonable reaction intermediate for the following reaction. So this is a very, very interesting question. Okay, so why? Because here ring breaking will happen, then again ring formation will happen. So what exactly we'll do here? Firstly, this thing is given to you, right? Firstly, we know that we have OH negative here. So OH negative is going to attack either side, right? So electrons can jump here also, it will give positive charge here. Electrons can also jump here. Now you tell me, positive charge is more stable here or here? Positive charge is more stable here, not here. Reason being, this is 3 degrees. So that means the electrons will jump on this side. Okay, so 3 degree carbonine is more stable. Electrons will jump on this side. This will be positive, this will be negative. To this positive side, OH negative will attach, and this will be your negative, and hence you have negative here and OH here, right? Now what you will see here, this is negative, this is O negative, H positive. Now ring actually will basically, what will happen, this is the most crucial step. This and this step is the most crucial step here. So now what will happen, we know that this is O negative, this is H positive, this is negative. So whenever proton is always, proton is like, you know, that guy in the class that who will fall for every girl, right? No taste, nothing, every girl, right? So this is proton. It will see this negative, it will directly shift there. Proton is not very difficult guy. Okay, so this is H positive, it will jump, not at all a sigma male, right? So H positive will be there, right? Proton, that means proton intra transfer will happen here, right? So once proton is shifted, after that here you will have O negative, here you have H, right? Now this O negative, okay, this O negative, this negative will shift to this side, right, making a double bond. Now ring breaking, this is a very, very important step. Now this sigma bond will shift to this side. So here can you see what will happen? This is carbon, this is carbon, this will be C carbon, this is CH3, this is, you can't say CHE, you can just directly write it as, let's say, because this double bond is shifting here, this will be ET, this electron is shifting, wait a minute, it's not like this, it's not like double bond can't shift here, you can't form double bond, it cannot be like this is not possible, right? That means here you will not have double bond, right? Here what you will have is negative charge. When this electron is, this sigma electrons are jumping, it will jump to this side, right? What they will form, I'll just draw it, double bond, this will be CH2, or you can just directly write the same thing here, this will be negative, because the sigma electrons have shifted here as negative. This is 1, 2, and this is 1 ethyl, as it is I'm writing, this is double bond, okay? This is the thing that you have in the end. So I'll write this thing similarly here. It is C double bond O. This is ET. This thing is CH2 CH3 ET. This is CH2 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 C double bond O, and this is CH2 negative. Got it? That is how I have drawn it here, right? So now after this they are saying that, you are adding water, right? So water, it is already there in the solution, right? So we know that this CH2 negative is not stable, it will abstract the proton from somewhere, right? So it will abstract the proton from here, and hence in the end this will be your answer. That is the intermediate that you are going to have. So that is why here you can see that C is the intermediate, like this is CH3 C double bond O, CH2 CH2 C double bond O, ET. Same thing, CH3 C double bond O, CH2 CH2 C double bond O, ET. After this again ring formation will occur, right? Again what will happen here? Intra-aldol. So ma'am, what is intra-aldol? This itself is a big problem here, that what is like, it itself need one different page here to answer this. So what will happen here? This, if you see, this is your carbonyl, right? If I take this as carbonyl, this will be my alpha, right? So what will happen here? Alpha carbon and the carbonyl. See, this is also alpha. We know that this is CH2. This is also alpha. This is also alpha. Now here the ring formation is small. So always high ring formation is preferred here, more ring formation. So it is 1, 2. If this carbonyl attacks to this alpha, it will be 1, 2, 3, 4, 5. 5-membered ring is more stable as compared to 3-membered ring. So it will prefer this alpha, not this alpha, right? So that is why what will happen? This will be converted to OH. This will be converted to OH here. I'll just write where to write. Okay, where to write. So I'll just write it here. This is CH3. I'll just draw the ring here, okay? So this is a 5-membered ring, okay? 5-membered ring. If I take this as COH, this will be converted to OH, right? To this you have this OH, you have the formation of 1 CH3. 1 CH3 is linked here. This is CH2, CH2. Then you have C double bond O. This is double bond O, right? And here you have after the C double bond O, this is the last carbon which has 1 CH3. Okay, this is how it is. We know that after this condensation step will be there, OH negative from the alpha and beta. This is alpha, this is beta. From this position H will be eliminated, right? So here what you will have, this is 1, this is double bond O. Alpha and beta, water will be eliminated. So this will be a double bond here, right? This is 1 methyl, 1 methyl. So it's the same thing, right? Okay, you can see it here. I have made it on this side. They have made it on this side. That is the same thing, right? So in the answer also it is given to you, right? So that means we have drawn the intermediate right. Okay. I've just, it was, the intra-aldol condensation was not needed here, right? You already know that after this it will be formed. But I just told you, what if they ask you question from only this step, the conversion of this into which compound? So for that, you should know what is intramolecular condensation, right? Next question is increasing order of rate of reaction with HNO3 and H2SO4. Now HNO3 and H2SO4, right? If you talk about here, this is nitrating mixture. We know that this will give you NO2 positive as an electrophile. Now electrophile needs electron density, right? Okay, that means we need to see which has maximum electron density, right? More the electron density, more will be the rate. Okay, they are asking you the increasing rate. And we know that if you have oxygen, if benzene is attached to any group that has lone pairs, it will donate the electrons. If benzene is attached to any, let's say any group or atom which is further attached to a electronegative element with a multiple bond, right? So in that case, it will show you minus I effect. It will take away the electron. So here it is increasing the electron density. More is the electron density, more is the attack of the electrophile, right? So here we can see you have OCO, right? Here you have OCO, okay? Here you have COO, here you have O. So I'll just see the first thing here, right? I'll just see the first thing here, because here to this benzene ring, I have two oxygen that is going to donate the electrons. I have oxygen that is going to donate the electrons. So it has high electron density. Here I have one oxygen that has lone pair that is going to donate it. But then here I have an atom that is carbon, which is less electronegative. Oxygen is more electronegative. So it is going to take away the electron from this, right? Here I have both the carbon, both are going, this is also going to show minus M, this is also showing minus M. This is showing plus M, this is showing minus M. This is showing plus M, this is showing plus M, right? So I can see that more the plus M, that is more is the donation, more is the rate. So that means third has maximum rate, then second, then first has minimum. So D is going to be the correct answer here. Is that clear? D is going to be the correct answer here, right? Next question is a rank of order of increasing rate of reaction towards EAS with bromine in the presence of FeBr3. So now here you have bromine. So again, electrophilic, this is the same kind of question, right? This I have specially put just for you so that, because I want this answer from you. I want this answer from you. This is again electrophile. Again, we are looking for electron density. More is the electron density, more is the electrophilic substitution. Let us see how many of you are able to answer this. Same question, same kind of question. The format is different here, right? The format is different. Otherwise, it's the same kind of question where you have this is benzene, this is benzene, this is benzene. We know that in these three cases, here you have lone pair. It is going to provide plus M. This is C double bond O. It is minus M, right? It is going to take the electron here. This is showing both. It is donating the electrons to this. It is taking away the electron through this, right? Minus M and this is plus M. So maximum we can say is for C rate. Then it is balancing it out. It is also taking away. It is also donating. So it will be A. Last one will be B, where you are just taking away the electron. So it will be CAB, CAB, CAB. So answer will be A is the correct answer here. Right? A is the correct answer. That is CAB is the correct answer here. Okay? Understood? I think we are about, yes, this is the last question of today, guys. Last question of today. Let us see. Catalyst A reduces the activation energy for a reaction by 10 kilojoule per mole. The ratio of rate constant with the catalyst, when it is catalyst is there, without catalyst, right, is e raised to power x, the value of x. So let us solve this. Very simple. We know that K is equals to A e raised to power minus EA by RT. right? Okay, so you need to solve the value of k, right, which is given in the form of exponential only. So we know that the ratio we have to take, so k with the catalyst, see, they have given you the value of delta EA, that is 10. That means energy change is 10, right? So here we can write it that K with catalyst, right, is A with catalyst, let's say with catalyst activation energy for reaction by this at the ratio of catalyst to the value of X. Okay, so I can take anything here. I'll take with catalyst, it is dash, without catalyst, uncatalyzed, A is same, this is e raised to power EA by RT. You can see if you take the ratio here, this is same, this is catalyst by uncatalyzed, this is e raised to power minus of EA by RT, this is dash, this is plus, this will be minus of minus, that is plus EA by RT. So it is going to be e raised to power minus, okay, you can take 1 by RT here, है ना? R is given to be, T is given to be, है ना? R is also given, T is also given. So what I'll do here, this will be minus delta EA by RT. Delta EA is given to be 10, right? So minus 10 by RT, right? That is going to be the value. You just have to solve it then, e raised to power something. So this is the X value that you have. That is delta E is given to be 10 and RT, R is, you know that 8.314 and temperature is given to be 300. Then put all the values, you will get it, right? So it is this you have to solve. This is given to be what? 10 kilojoule. Right, so we will put the value 10 multiplied by 1000, that is a kilojoule. R and T, you put all the values, you will get it as 4 point something. That means e raised to power X you have to equate it, so X is equals to 4 here, right? Okay, so answer is A is the correct answer. Okay, is that clear to everybody? Yes, students? Okay, so now, and if you like such videos, don't forget to hit the like button. I see you guys come here, join, but you don't like the session, you guys don't comment, right? So I also want my students to comment and to like the video so that I can also get motivated. What if you solve all the questions in the exam, but the teacher says 0 marks, right? You will also feel like, I don't want to do this, right? So we are also humans. We also need appreciation. We also need your feedback here, right? So that's why do hit the like button here, do share it with your friends, and do comment down that what exactly you need for BITSAT more, right? And for all the students here, as I told you before also, so this is the BITSAT test series. In the description box you will see BITSAT test series, 10 mock tests are provided to you. That is for 649, just for 649, right? So you can just click on here. You still have time, right? You have enough time to practice 10 mock tests here, or the solutions will be provided to you in the mock test only, right? So it's a full syllabus mock test. Now what you can do, you can solve it on a CBT format also, so that will really help you to manage the time in the exam, right? So time management is a tough thing in the exam. Even if you know all the answers, right, you're not good in managing the time, right? It will be very difficult for you, right, to understand that which question you should do, which question you should skip, right? So for that, this BITSAT test series is going to be very important for your exam. Okay, you just need to click on the description box here, and all the other test series are also provided. If you can see extra mile engineering test series, if you're looking for like multiple test series, that is provided at 1299. So that is a benefit to you. See, let's say you want to purchase test series for 3-4 different exams. Better will be purchase extra mile engineering test series, because 6 into 3 will eventually go beyond 1200. So better will be purchase extra mile engineering test series, where you will get around 100 mock tests each. Let's say BITSAT, JEE, SRM, VAT, EEE, different mock tests. So each exam will have 10 test series each, right? Okay, So that's it, students, for today. Bye bye, take care, and I'm waiting for your comments in the comment section. Bye bye, take care, see you all in the next session. And for those students who are preparing for JEE Advanced, and so students in IIT Kanpur has released the sample paper, so I'm going to take the IIT Kanpur sample paper at 6 p.m. today itself. So do join in the session, because really brilliant questions are asked in IIT Kanpur sample paper. So you'll see you all at 6 p.m. if you're interested in high level questions. See you all. Bye bye.